Now we're going to move on to Jessica Knickerbocker from the city of Tacoma.
All right, well, thank you very much, and thank you, Curtis, for the great introduction. So I'm going to cover going over the general overview of the technologies, and I'm going to do that through a number of projects that we've done here in Tacoma, case studies, and how those projects led us into the community of practice. So there are several options, and Curtis alluded to several of them: the porous asphalt, concrete, permeable pavers, the grass options or gravel paves. There's several options out there, and there's good guidelines, but you really need to think of each site individually and holistically. It's not as cookie cutter as standard pavement, and you really need to think of it as a system, and where's that water going to go when it goes back into the ground. So one of the first ones will be the gravel pave option or grass pave. We've got a large show field at the LeMay Car Museum, the largest car museum in the world, and that installation has shown us that it's a really good application when there's not a lot of traffic on it. There's several manufacturers out there that make grass or gravel paving structures, and they've got varying recommendations, but most of them are around the less than 5 passes per day. A couple things to keep in mind is, especially getting them established, it's really important that they have irrigation and also access to sun. So when you're thinking about some of the trails that are out there, you might want to consider going with the gravel pave if it's in a heavily wooded area. I know some of the jurisdictions have looked at putting porous asphalt or concrete in some of these trails and had challenges getting them maintained. So there's a couple of good options out there. Tacoma Community College is got a huge commitment to permeable surfaces. It's actually in their master plan. In 2008, they installed this parking lot with the Eco-Lock paver, and it is holding up amazingly. It's kind of bumpy to drive over, so keep that in mind. We don't have any roadways that are made of pavers at this point, mainly parking lots, but we are considering it for some of our historic districts that have pavers already. TCC also has their roundabout at the main entrance to the college is made of pervious concrete, and it is holding up well. I think that was installed in 2009. And one of the things about that is you can see the very tight turns, and those seem to be a maintenance problem. As I'll explain a little bit later, the regenerative air sweepers, your traditional turning radius that you designed for is not the same as the vacuum portion of it. So the vacuum portion of the sweepers is only under the wheel wells. We don't have any entirely concrete roads in Tacoma at this point, but we have used porous concrete in a combination approach. So on the left there is a residential project where we have standard HMA drive lanes and then pervious concrete in the drive lane or parking lanes and then the sidewalks. On the right is an arterial with a similar design. Something unique about this application is we extended the reservoir layer underneath the sidewalk. So there's rock underneath the pervious concrete parking lane and then under the standard sidewalk and then 2 feet onto the residential property, and that's covered with grass. So we did that to capture the run-on from the residential properties. And then also there was some contention about if we made the sidewalks pervious, if it would become a stormwater asset. And right now in Tacoma, the sidewalks are maintained by adjacent residents. We are working on a policy to identify which surfaces are assets and which are not, and generally the permeability of the roadway is going to be an asset, but the structural is going to be a road. So if there's a pothole, then the roads folks would take care of it, and if it needs to be swept or the surface needs to be replaced to keep its permeability, then that's on the stormwater utility. So some of the challenges that we've seen on our projects that have the run-on, in particular in this case on Alaska Street, the arterial, new HMA tends to leach. So we heard this from Bellingham and some other applications that within about the first 3 years, the asphalt breaks down in the summertime and will clog up your pervious pavement very quickly. We had to sweep this about monthly during the summer times, and in this last summer, it didn't degrade like it was. So we have found that normalization point, which is good. This issue was compounded with the vacuum sweeper turning radius I talked about before, and then also we put in gutters in this design. And some of the issues with gutters is, of course, it takes the runoff from the driveways and puts it into a point source, and if it doesn't have a place to go, like a catch basin or an overflow infiltration gallery like shown here in this picture, then it's going to start clogging up your pavement pretty quickly. We have found that sweeping the streets twice a year has been more than adequate to maintain the porosity. Here are, on the left is a residential roadway, public residential roadway, and one of our first, we actually were fortunate to receive a grant from the Department of Ecology to replace this failed roadway, and this application was about half the cost of traditional improvements for this watershed. On the right you see an alley. We've got almost a half a dozen pervious alleys at this point. They're generally, they trip the water quality requirements because most of them are gravel, and so the porous asphalt provides that treatment if the existing soils provide the treatment. And then also, as you can see and imagine with alleys, a lot of them have garages and walls and other things that make it hard to tie into, and we found that pervious pavement is a really good application for that. Some things to keep in mind if you're looking to use porous asphalt: there is kind of a minimum quantity that you want to have, so you probably want about 500 tons for your project. Otherwise you're going to pay for 500 tons no matter what. And then also the oil, the 70-22 oil that's required is limited to more of the summer months, and it's less available in October and April. So think about that when you're going to bid projects. Not saying that they can't find the oil, because there's oil around, and don't let anybody tell you there isn't, but you may come with a premium. Cheney Stadium was one of our first and most recent projects. We broke it up into 2 phases. It's our minor league baseball team, and we have about 6 acres of pervious pavement, and this site had very poor soils, like 0.05 inches an hour, and yet we were able to make pervious pavement work here and reduce the flows for about 11 acres, which is pretty impressive. About half the cost of traditional improvements. This site is located in a fresh watershed, and we would have been required to meet forested conditions for this site, which would have been pretty expensive. We have seen some raveling in the parking lots, and that has also kind of normalized itself. The first 2 summers you saw some of the raveling, and that was mainly caused by the hard turns and the hot weather. But overall, it's structurally holding up well and working far beyond our expectations as far as stormwater goes. I'd also like to point out that this area right here in the center is about almost exactly an acre, and surrounding that there's about 5 acres of run-on to it. So it far exceeds the recommendations that are out there, and we haven't had any clogging issues with it. Now, I think that it tends to the loading on it. So it's a parking lot for a baseball game. It's not like the arterial we saw on Alaska Street. So it's really important that you think about your roads or your project holistically and what kind of impacts and loading you're going to see. So this project had a number of, well, all of our projects we've had a number of very valuable lessons that we've learned, and particularly on this site we had an issue with the rock that was specified. So our traditional state DOT specifications for the permeable ballast are for roads that aren't exposed to water, right, or traditional roads. And so when you expose them to water, the rock can potentially chemically and mechanically break down over time. And in our specifications, we didn't have those requirements as high as they should have been, and we actually saw the rock starting to degrade on site while the trucks ran over it. So we had to replace it. It was a pretty painful lesson, but very valuable in and of itself. The other issue we had on one of our sites was that you can see there's a core here from one of our asphalt projects, and we had raised our specifications for the oil content to the recommended 6%, and the contractor gave us somewhere around 5.1. And so, we went back and forth with them on that, and they said, well, this would have met the specifications in another county, and, it really came to light that all of the municipalities and design engineers were using something different, and it really just hammered home the need for industry standards. So that's when we came to building our community of practice. It's a huge risk for particularly smaller municipalities or engineering firms to develop these specifications on their own. So that leads to the fear and some of the barriers that have been seen. There's also a number of contractors that complain about these different technologies, and also, like I said, there's no industry standard out there. But when you weigh that against the needs for permeable pavement, you have the impacts to Puget Sound, the stormwater requirements that are pretty much requiring it now, and then in Tacoma, which I know we're not unique, but we have over 50% of our roads are in a failed condition, and so we need to find a way that we can rebuild these roads and do it without impacting the environment. And of course, I would have to highlight the grant opportunity that's out there. There's not a lot of financial assistance for the smaller residential roads, but the grants from ecology have been very helpful. So how do we get there? I was presenting at Roadmap, a group of stormwater municipalities, and giving all of my lessons learned on our different projects, and ultimately came to the conclusion of we need these industry standards, and what are we waiting for? So we started there and started getting a group together of local experts and professionals that were doing that, and we met for a half-a-day workshop, and then we gathered all the specifications that were out there in the region and reviewed those and decided that we were pretty close to a spec, but we needed to break down into 3 smaller groups and dive into some of the details a little bit more. And took about a year, but then we got back together in April of this year and pretty much settled on some specifications for permeable pavements. And this is all the logos from those that were involved in this process. And I'd like to really point out that we have municipalities, consultants, industry representatives, civil, environmental, geotechnical, and in my opinion, most importantly, the materials engineers and materials testing firms. So these are the specifications that we focused on the most, and the first is the inspection and work of materials, and this kind of gives a good guideline for what the contractor can expect and what the inspector should be looking at during the different phases of construction. Curtis touched on the subgrade preparation a little bit, and we talked about the ballast. The porous asphalt is very similar. We worked very hard to get it to look very similar to our DOT spec with some minor modifications. We really tried to get this to be more of a performance specification than the prescriptive that we've been used to. The concrete one was much more different than standard concrete and is actually a brand new section in the specifications. So where do we go from here? What's next? We really want to, or my vision is that we move forward together, that we all learn these lessons together, and we improve. I think we can improve at a much faster rate than we have been. So the task force is, we met and we decided that we're probably going to get together again in a year. We have a Google group to keep in contact throughout the year, and we'll be posting, it's available to post questions and then also to make announcements like future paving projects or different things that's going on within the region. So with that, I open it up to any questions.
That was great. Thank you so much.
I can answer one of those questions that Christina had about the overlay. An overlay that was done, I believe it was the City of Vancouver did one at a police station. So it has been done. It was successful. We haven't had to do one yet, but it has been done. The specifications, here, let me type it in. The specifications are right now on a city website, but there will be, we are looking to get it on into the APWA specifications. How many years has the Cheney parking lot been stable from raveling? So it was really in the first 2 seasons that we saw any raveling. It hasn't degraded since then. We have one section of the parking lot that I wasn't involved in that was installed about 9 years ago, and that's also in a pretty stable condition. We haven't had any permeable pavements that we've had to repair based on potholes. We did have on one of our projects a water main break underneath the standard road. It was like right on the edge of our permeable concrete and our asphalt road, and the water department went out there and replaced it, and there was no, they didn't even call, so there was apparently no issues with it. Long before a road would plug up 100%. That really depends on the application and what kind of maintenance you're planning for. The City of Chicago put out a study on different types of cleaning mechanisms, and what was kind of the recommendation was about twice a year, and that's what our maintenance cycle is, and it seems to be working. My opinion is if it can't be maintained with your standard road or your permeable road shouldn't take any more maintenance than your standard roads. We already sweep our roads twice a year, and the areas that need additional maintenance could be fixed with additional considerations in the design. Most of the time you can patch back pervious asphalt with standard HMA. There's so much underneath. It's, unless you're replacing like half the road, if you just have a small patch or utility trench, you can replace that with standard.
So Jessica, do you want to address freeze thaw, or should we wait until later for that?
I can take a stab at it. We haven't had any issues with freeze thaw on our roads. We've had installations for over 5 years now, and it just, you know, the freezing is below. We've never had it get into the upper surface. I know that Minnesota has more of an issue with freeze thaw, and so does Chicago, and they're still putting it in.
So I think at this point we may have to wrap up the questions. So thank you so much, Jessica. You did a great job.